Welcome to everybody. Welcome to the people who've decided to spend this morning with us. I know it's a hard time because it's in the morning on a day week, so many people are working. But it's interesting to start this ISEA 2022 Barcelona with this first event that I think it's going to be very, very interesting. We will talk about quantum, arts, and uncertainty. And here we have two big totems to do that. First of all, we have Paul Thomas. He comes all the way from Australia. He's traveled a lot to be here with us. He's an honor professor at the New South Wales Art and Design University in Sydney, Australia. And he's the director of the Studio for Transdisciplinary Art Research, STAR. As an artist, he's a pioneer of transdisciplinarity art practice, and his practice-led research take not only inspiration from nanoscience and quantum theory, but actually operate there. His publication about quantum art and uncertainty is something that shows us his interest in quantum and is why he's here to talk to Maciej Lewenstein. He's a theoretical physicist. He's an ICREA research professor at Institut de Ciències Fotòniques, ICFO, and his interests are very wide. He is interested in quantum optics, quantum physics, quantum information, nanobody theory, attosecond science, and statistical physics. And he's passionate about jazz and avant-garde music. In fact, he's also done as much work in physics as he's done in music, no? Not as much, almost. He works at ICFO leading a 35-people team, and he just receives the National Prize of Research Award by the Catalan government and the Catalan Foundation for Research and Innovation. So here we have two people really involved with art and science. I don't know if 50-50, but quite a lot, no? Both of you. And I think because we are going to talk about quantum, and quantum physics is not that new, but is one of the newest branches of physics. And I would like to know how did you start working with this field? How did you felt interested in quantum concepts, Paul?
Okay, quantum came about through my practice as an artist who's been primarily focused in questioning spatiality, the space between us, and the space between us and objects. And as I started to research this area, what started to happen was it became very reductive. It started to focus in. So I started out by taking this kind of idea of space and gradually investigating it further in a sort of macroscopic way, a microscopic way, taking the space. You're sitting on cushions, and so in the early 1900s people would say, futurists would write about you become part of the cushion you're sitting on, and so you become part of the world around you. And this fascinated me for a long time. I didn't know why when I was a student that this fascinated me, but it stayed with me, and I started working with nano. And I wanted to know, when we touch gold, how much of us became part of the gold and how much of gold. And I called it Midas because of King Midas, and how the desire of touch changes the way that we actually think about things. So instead of, and because the atomic force microscope uses touch as a method of seeing the world at a nano level, it seemed to be very interesting idea. So fundamentally it came that way. So I started working in with nanoscience, and then of course suddenly there's this idea that there's this space between us and the quantum world. It's like there's this classical world and then there's this quantum world, and I became fascinated in that idea of a liminal space between the two. I think that
so yeah, it's interesting that you've usually artists focus on the side, no, on looking at things, and you change that to the touch, but like microscopes that they, no, optical microscopes, they change from looking to those microscopes that they touch. At ICFO, I'm sure you have the microscopes that they touch.
Yeah.
So, but you didn't start in ICFO because you come from Poland. How did you felt interested about quantum?
Well, I am a physicist. I studied physics, so it was quite natural. In fact, I did my Master of Science thesis in Warsaw already on quantum optics. But I would say in those old days, this is the 80s, I was treating quantum mechanics as a kind of tool to calculate things in theoretical physics. So I was not really having a lot of reflection on what is the essence of quantum mechanics, where are the deep quantum mechanical effects and things like that. And in fact, my PhD was still about quantum optics, but then right after PhD, my mentor Fritz Haacke told me that quantum optics is not a separate discipline of theoretical physics, you should start doing other things. And then I started to work on classical statistical physics, spin glasses, neural models of neural networks and things like that, so classical stuff. And then I would say the most decisive breakthrough to my attitude toward quantum was in the end of the 90s, where I started to think about quantum information, and in which the really specific quantum correlations and properties of quantum states, properties of quantum processes are very important. So this is where you start thinking back about the fundamentals of quantum mechanics and about all these paradoxes or pseudo-paradoxes and about the non-intuitive meaning of quantum mechanics. And that was it. And since then I started to be very much in the quantum, in particular from the context of, in the context of this quantum information, also with the many-body system, as we call them. So systems which not only consist from one or two particles, but consist of many, and therefore the quantum effects are more complex and more hidden and more difficult to understand.
And you've traveled through many parts of physics, so you have a wide vision of physics. Could you describe to us what is quantum for you? What means in your work? A bit simple. Like, I know you could talk for hours, but if you had to summarize, what is quantum in your work?
Well, when I give the talks to the general public, I usually stress for let's say, truth about quantum mechanics that you should know, but you never dare to ask. Paraphrasing Woody Allen. One of them is that indeed it's very difficult to understand that particles in quantum mechanics do not have a definite nature. They can behave as particles or as wave packets or droplets of quantum matter or something like that. So it's what we call particle-wave duality. And this is something which is very important because it really breaks the classical concept, because if you have a wave, the wave can interfere, which we know from light or things like that. When you add two waves, they can cancel each other because they have exactly opposite amplitudes. If you have two particles, you add them in classical physics, they cannot cancel each other. There is no way. So these are the things which are this duality is one of the very important things. Duality allows for superpositions of states, which is exactly like these waves, that you can add them in a kind of arbitrary way, and then you can cancel one another or amplify one another depending how you do this superposition. The most known superposition, of course, in the popular knowledge about quantum mechanics is the famous Schrödinger cat. Schrödinger at some moment of his life proposed this kind of quasi-paradoxical model in which you can have a cat in the state which is alive and dead at the same time because you have a superposition. Now, if you observe this cat, usually observation is a very macroscopic process of measuring what is going on. If you observe, then you observe that the cat is either dead or alive. It's very difficult to observe this superposition. Indeed, we can observe them, but only with the systems which are not too big. For the macroscope, we never seen the true cat to be in the Schrödinger state. So this is the superpositions. Another thing which is related is, which I mentioned, when you measure, it is like coming with a hammer to a microscopic system. I mean, you measure and you hit it. I mean, the measurement is interaction with the environment, and this usually destroys these superpositions, which are very fragile. Okay, and this is one of the problems with quantum computers. Indeed, they have to interact with the ambient, with the environment, but they are they have to use the superpositions, and the superpositions are fragile. So this is why it's very difficult. And the last thing which I always say is entanglement. This is a form of quantum correlations for many party, or let's say two-party system, Alice and Bob usually called. And these correlations are extremely strong and extremely difficult to understand in the intuitive way. I was talking too long, so...
No, that's perfect. You point at the the quantum truths, I think you call them. Four? It's particle, wave duality, superposition, measurement effects, and entangled systems.
Yes.
Yeah. And is for you the same when I use the word quantum? What is for you?
It's the relationship between a kind of classical world and a world of probabilities.
Okay.
So suddenly probabilities really fit with art more than most other sciences. So everything that was just mentioned in the quantum mechanics stage actually happens in art to some extent. So when you make a mark on a piece of paper, at that moment you're actually collapsing the world. You're making a measurement, and the world turns from something to something else. And when you go back, you can see the mark you've made, and you're actually engaging back into a world of questioning the probabilities of whether things exist or don't exist. And when you draw an object, you become potentially part of that object. So, like so you become almost entangled with it. It's actually watching you, watching it, you're watching. And so you could say that these things are similar. I'm not saying they're the same, but I'm saying that they have a similarity. So Giacometti's drawings are about probabilities and the impossibility of drawing. So the impossibility fits with the fact that you cannot draw it. But the beauty of the human expression is to draw something that can't be drawn, to keep on attempting to draw something even though you know you can't do it. And that's what creates beauty, in this constant questioning of the world. So you get entangled, you start to deal with the collapse wave function, and I like the notion of conscious induced wave function collapse. Only science can come up with these names. You know, you thought art was bad, but they are incredible what they come up with. My absolute favorite is counterfactual definitiveness. And counterfactual definitiveness is all the experiments that you don't do to prove the ones that you do. And when you make a mark in drawing, you are making a mark that's actually taking all the possible marks and not doing them and doing the one that you do. So you're seeing this whole relationship between quantum physics happening at the very simple thing of using a graphite pencil. And then you say, okay, let's look at graphite. What's graphite? Graphite's carbon. What's a single sheet of carbon? It's a nano. It's
grapheno, no?
Yeah,
like graphene.
Yeah. So now you've got graphene. So every time you're drawing a line, you're laying down areas of graphene, which is really a fabulous conductor. So it potentially has transmitting more from your body through your hand than what you think it is. It's very much like an AFM. It's touching the surface and transmitting emotion. Imagine that you love your child, and when you touch it, you're touching it with tenderness. Then could you draw with a pencil expressing tenderness? And would that be recorded in the graphene? I'm just asking.
It's nice how to see this metaphor and how you link everything. And it's funny about the language. I don't know if you want to do some exchange of language, but it's true that each field has its own way of talking, and sometimes it's interesting to get it from another point of view. In this way of thinking, maybe quantum could be thought in the big world, because quantum in physics started for the really, really small world. But if we apply in this metaphorical way of thinking, do you think, Maciej, that quantum implies postmodernity, or we couldn't talk about this?
Well, I don't know what's postmodernity, but evidently I'm a great enemy of everything which is related to the so-called cognitive relativism. So the philosophical, one of the philosophical tendencies of postmodernism, which says that there is no objective truth, there are only local opinions. And so I'm against it, and I don't think quantum mechanics is like that. But quantum mechanics definitely, so one thing that Paul has said, it's intrinsically probabilistic theory. Okay, so it doesn't give you predictions which are 100% sure. Sometimes it does, but mostly not. And this is something that you might like. Einstein didn't like it. He even suggested that God doesn't like it. But why not? Okay, the randomness itself is a very beautiful property, in fact, which can be used in art, in visual arts or in music, and is being used. So it's not something very bad. And on the other hand, the other property that also Einstein didn't like is that how do you call them? Well, let's say properties of the things, like color or like, I don't know, position or velocity, they are not predestinated for the quantum mechanical objects. You have to measure them in order to check what they are. Many people interpret this as a kind of lack of objectivity or subjectivity, because I choose the measurement, so I choose therefore what the property of the thing is. But I think it's misunderstanding completely, because everything is objective. I mean, in classical physics also, if you measure that thing or that thing, you get other results. They are maybe predetermined, and here they are not, but still the prediction of the measurements are quite well described in probabilistic terms. So in these things, I don't think that quantum mechanics is not, does not have objective truth. Quoting Indiana Jones, it's archaeology is about the facts, and quantum mechanics is also about the facts, except that some facts occur with certain probability, and we can only predict the probability. However, when we measure a thing and we get the result, we know that it occurred, and we know the state in which the system is with certainty. So in a sense, this is what is my opinion. So it's a kind of, I don't like mixing this cognitive relativism and postmodernism with interpretation of quantum mechanics. But of course, it's very helpful for this general analogy that Paul is saying with the art is very helpful, both for artists and for us to understand better intuitively quantum mechanics, and for them to maybe make inspiration from quantum mechanics in art.
I absolutely agree with, there is a lot of misunderstanding with quantums, and it's good that you mentioned it doesn't break if it's true or if it's not, it breaks the determinism. That's a very important step,
yes.
Because the big change is with classical physics, we knew everything in advance. And with quantum, we know probability of something, but we still have some truth or some facts, as you say, because sometimes people have thought, in fact, Greeks thought, Plato thought that we live in a cave and we just saw the shadows. So some people think, well, science just thinks to get to know the truth, but they don't really know the truth. How do you feel about that?
Well, it's the same thing. I mean, I'm against this kind of, let's say, for me it's a kind of ideology. I mean, of course we never know everything. This is something that we have to be aware. But certain things we know for certainty. And of course you may say that when we observe something microscopic, we observe the shadow of it, because we don't have all the access to all the measurements. We cannot do everything at the same time. And therefore we can only have partial information and things like that. But this information is predictable with certain probability. And for me this is an if you wish, postmodern form of objectivity. Okay?
That's good. It's true that we cannot see what is smaller than the wave of light, because it's impossible for our sensors. But still, we are learning things that they are facts. Science looks for how things work, and they get to know these models. I don't know if can quantum mechanics inspire art in a way that because all these things we are talking about things we cannot see. In fact, they are microscopes that they just touch, as you say. We are talking about things that they are a bit anti-intuitive, because it's about probability, not determination. Do you think art can help us to understand this in a better way, or can do something about the understanding of this? Or it's not about understanding, it's about feeling? I don't know.
Well, the making of art and visualizing things that can't be comprehended has been part of art's history, is to try and explore that. And in relationship to measurement, when you look at Duchamp's 3 standard stoppages work, where he dropped a piece of string 3 times, and each time he dropped it, it created a different length. And so then he started to develop works from this, was really questioning this notion that was becoming popular around 1917 of questioning art, of chance, of the way these things affect, and that things can't be measured anymore. And so therefore we get this history, and then you get the ideas of fiction. So there's a famous story of Waldo, who was a scientist, a fictional scientist, who built a robot, and to try and operate on himself, he built a hand, and then that built a smaller hand, half scale, and then that built a smaller, so he could operate himself on a nano scale. So then Feynman used him in his paper, Richard Feynman, to actually discuss nanoscale manipulation. And so you could start to say, well, does fiction come before the sort of fact that science picks up on, or does it happen the other way around? So we're starting to say, well, Duchamp's talking about that at the same time, predating Heisenberg by about 10 years. Bergson maybe predates a lot of the thinking, taking from the Greek Zeno's paradox about the inability to measure things with his. So it all starts to cascade together, I think, in a strange way. And everybody is just looking at it from different perspectives, but they're looking at the same sort of problem about meaning in relationship to our experiences, and how do we express those in a work of art is incredibly complex and brave of an artist to try and make a work that expresses something that can't be seen, and then to stand by it and say, this is how I actually feel it looks. This is, I mean, you can say it in words, like scientists use things like spin to describe something that isn't spinning, and so it's a blur, it's a smudge, it's not a spin. And so we all get confused by what they're actually saying. And I love the terminology like quantum tunneling. Is it really tunneling, or is it just some seamless flow through an object, at certain times? Is quantum scarring, which we talked about is that really scars, or is that some way of describing something? Because when you talk about scars, you talk about the whole history of scarification, of everything else that goes along with it. So picking up a word and calling it something doesn't necessarily mean the same thing, and so therefore we get confused. You start to think of a dipole and it's spinning around, but unlike, I've been working with speculative quantum chaos data with my artwork, which starts to say that they're everywhere, but they seem to be more pattern driven than classical chaos in the way that it actually works. And so sometimes the artwork is telling us things. You mentioned Feynman's well, you didn't mention, but you mentioned optics and Feynman's lecture on photons hitting a mirror's surface and how they go on the shortest angle of incidence. And you go, hey, that's incredible. So you mean that all of you now that are sitting there, all the photons that are bouncing off you are making you all omnipresent. So you're going everywhere. So if I put a mirror over here, you'd be over there, if over there, over there. So you start to think of all the way that we see, but there's multiples of you being omnipresent at any 1 second, and the trees and the ground and everything else. And it's just too much. It's just too much to comprehend. And so we're sorting it all out all the time. But what if you could start to see this? So I made an artwork that took your face when you looked at it at the shortest angle of incidence, so you could see you, and then the possibility of all the photons were coming in at all the angles, bouncing off. And then I started to find that in the far reaches of this mirror, you would reappear, distorted, a bit like Bacon's paintings of a distorted face, Francis Bacon. So then you get this. So thinking about that and thinking about Feynman and doing the mathematics, not properly mathematics, I'm just trying to pseudo-mathematics on this, you get this notion of Everett's multiverse coming out of this kind of thing, for me anyway. And so then it started to, the fact that you reappear in another world, like your photons could be reappearing in another world, and it starts going back to that whole set of possibilities that are beautiful for artists to try and consider, because they're such a wonder. It's like reading a poem and you find this beautiful line in it and it inspires you to do something, but you don't have to know about the whole history of the poet. Like a philosopher like Deleuze said something, you don't have to know the whole history of that philosopher. It just inspired you and you want to make something with it. And to me that's because I don't have to perform as an artist in any particular way with the information I've got. I don't have to find truth. None of these things are imperative. I can be disrespectful, I can be irreverent. So I can make all these assumptions about which a physicist has to kind of prove. They want it in a real world outcome. I don't have to have any real world outcomes. I just have to make art. And that's the beauty of it. But I love the ideas that are out there about this. But I love the fact that they're part of our whole history in relationship to talking about, the history of contemporary art. There's a beautiful artist called Roberta Matta that came to Europe, was in the time of the Surrealists in 1944, did a fantastic painting. Before why realism was still out there, and that the complexity of going from, because when you think about quantum, you can only really think of abstraction. The idea of painting something figurative just seems to go out it doesn't make any sense. So abstraction has to come in once quantum comes into the world. And so you start to see this as being causal, and that's 1926, 27. So when Heisenberg made it part of our conscious understanding in this, that you couldn't measure anything, then it opened up this whole set of probabilities. And then you've got Freud at the same time going, you've got an id and everything else, and you don't really ever know yourself. A poor artist never knows himself, and also he can't measure the truth. So it just opened things up, and we're still dealing with it in some ways. But I tend to think that uncertainty is the thing that we all have to come to terms with as a human race. I think this notion of uncertainty is really important. Not to always try for certainty, for success. I mean, failure, which is endemic in the sciences, they all have to really fail all the time. To fail and adapt from failure, I think, is really important. Mm-hmm. Sorry, I went off.
No, it's good. As you say, you need the mindset for science to arrive, it's true that eventually we try to understand the world, but we have our tools, and one of our tools is our brain, our prejudice, our background. So it's true that we need this mindset to understand. Even you mentioned Albert Einstein. He wasn't very keen with probability, uncertainty, and he said that God cannot play to the dice. So maybe you say we don't have to give any result, but maybe that's your result. Do you feel that artists are doing the social mindset? Are you trying to build so science can arrive, or science are making changes so artists have to adapt to create the mindset of society? Is this working in these two directions? Do you think? You can answer both of you.
To some extent, for me, it's to make something aesthetically beautiful. Whether I achieve that or not is something, but I want to make it so you don't need to ask those questions. When you look at a work, you start to say, what have I been given here? What has the artist given me? Rather than try and project onto it, I can see this in it and this in it. Just allow yourself to have that time. Because the beauty about art is that it goes into your eye and into your brain, therefore quicker than you can think. Mm-hmm. So it happens before thought. Mm-hmm. And then you start to think about it. So if you just allowed yourself to intuit more about what you're seeing, then maybe you could experience it better. You wouldn't necessarily come with all your prejudice about art. You would just give yourself over to it to see if it offered you anything.
I would like to use this word aesthetics that you mentioned, because I think physicists and science in general, but physics has a lot of aesthetics. Do you agree? Or
yes, of course. I mean, if we're coming back to Einstein, one of his criterion for the theory to be true was that it was beautiful. But coming back to your question about the social mind, I mean, I have maybe more kind of down-to-earth attitude to it, but the truth is that we have to educate society, because society is not educated, and then it's sensible to all the idiotic populism, fascism, etc., as we see in our world all over around. And of course, it's very learning about science and things like that is education. Now, popularizing science is a very difficult task, and still, even if you do it very well, it usually is addressed to not so large number of people. Okay, some people who are interested in science will try to get something from it, but the others not so easy. Therefore, in my opinion, educating through art, science through art, is a very useful thing, because exactly if you try to somehow transform the ideas of science through the artistic thing, which includes aesthetics and the beauty, then there is, even if this is abstract art, which is also niche, but anyway, there are much more people who maybe are attracted to it and may understand and get educated a little. This is in my kind of practical way of seeing social mind. That's why I think it's a very useful activity from our side. Okay, for him it's active because it inspires him and many other artists. Okay, so I think it's a very interesting kettle where these two ideas can melt and can influence one another and be useful.
And when you work with musicians, because you've done things with quantum and music, do you also see this going around, this inspiration? Are you looking for this focus as well of getting beauty, getting people inspired, understanding?
I'm not an artist, so for me it's very difficult to create a work of art which is beautiful, because I'm not an artist, but the people with whom I work are artists. And then, of course, I mean, I admire the fact that they do the things which are beautiful.
So we could relate art with aesthetics and beauty. Could we relate science with logic?
Well, science, yes. I mean, always, because logic is the basic of all the way of thinking and so on. So in this sense, yes.
And are pieces of art science, do they need to introduce logic somewhere, or do you think, as you were saying before, they can play and forget about that and that's just for scientists?
No, it's not. I mean, I don't think it's any of those things. You know, it's like trying to make two camps, like the difference between art and science, and there is no real difference. It's a form of inquiry, and to start to make a differentiation. At the moment, we've got where science seems to be the more powerful tool, let's say, and art is not as powerful in that way. But I see them as both having the same objective. It's a form of comprehending the world, and you know, an artist that spends their time making artwork, trying to discover something. Like in media art, a lot of artists have tried to understand our ongoing relationship with emerging technologies, which have really done a number of different things to us as a society. And so in the early days, when you look at some media artwork, you can see how artists have utilized things. We look at A Hole in Space, Kit Galloway, 1980, and Sherry Rabinowitz, who did this amazing work in Los Angeles and New York, where they just had two screens showing live footage going from A to B, which amazed everybody. They couldn't understand what was actually happening. They thought it was just actors on a TV screen, but they got satellite coverage to do this. So like the first sort of Skype call, you know, they did it, and they showed it in a way that they didn't advertise it, so people just came upon it, and it became this work, and now we're all doing it, and so now we look back at that work and go, wow, wasn't that amazing that it foresaw this whole kind of cyber culture cafe thing. I know we don't call it cyber culture anymore, it's like cyberspace. It's a sort of old-fashioned terminology, but cyberspace was a real space for us at one time. You know, for artists, it was this idea that there was this kind of new territory until it became you know, colonized by the industrial things like WordPress and everywhere else. It was this kind of open space, and then it became Euclidean. They gridded it, and then everybody knew where everything was in this space. But the idea of it originally was, for an artistic view, was really quite different. So I'm just saying, in a general sense, I think these things. So I like the idea of art, science, and humanities being, you know, sort of brought together rather than just art. Because I'm suppose personally, I'm more interested in what they call the fine arts, as opposed to the arts in general. Not that I think there's a difference, but there's just a difference in a relationship to some aspect of the context in which you're working in. You know?
And with this example, we've seen it as well. It seems that sometimes art can be, pioneers, or like they can imagine things that then they will become a reality. Do you think what they imagine, you were talking also about their language and their way of talking, what they imagine can change how you imagine, can make art in a different way? The question would be, can quantum inspiration generate new qualities in art?
Oh, well, I suppose I'm expressing that I think it has done. I think what it's created is, like, we've mentioned Einstein, Podolsky and Rosen, and that whole problem that Einstein had with Heisenberg and the Bohr and everything else. But so if you can imagine being at a time when that happened, and then it took until 63, I think, so from 27, and 35 was Einstein, Podolsky and Rosen, till 63, so 35 to 63, 1935 to 1960, before they actually proved or disproved that quantum actually existed. So up until then, even the foundations of it was speculative, because you had this argument going on. And so Bell and Bell's theorem, and so I think all the art that happened in that time was aware, you know, that there was this confusion in the world and we didn't know what was going on. And then I think it was then 20 years later, was it 83, that the French Alain Aspect did the experiment to actually prove, which I never like the word prove because but substantiate that at that time that had the appearance of being feasible.
Yeah, it seems like there is something going on and different disciplines catch it and study it in their own ways, but they are all interrelated. And you also work with artists, you said I'm not an artist myself, but I work with artists. How do you see this relationship between scientists and artists? Is it easy to work with each other? Do you have a lot of communication problems? Because I imagine you also work with scientists, or you work on your own?
I work on my own, but I work with, I work, let's say, in discussion with scientists. I've been very interested in the quantum computer and the capturing of an electron. And I love the idea of the capturing an electron in a huge magnetic field at sub-zero temperatures, this little tiny electron. And whether you think that, that old thing about so like, I haven't got much hair, and that's not why I wear a hat all the time, but it's true. But if you have one hair, are you no longer bald? If you have two hairs, so when does a bald man become not a bald man, or vice versa? So all these things start to become like part of this questioning process, if you see what I mean. It's a difficult area to explore, because you're always trying to deal with when does something become something else. So when is it?
When science becomes art, or when art becomes science?
Yeah. So it becomes a very, and usually there's an intentionality argument. Your intention is to make a scientific work, and my intention is to make an artwork, and the collaboration then is that, for me, is like the artist, then when we talked about the spin of the electron captured in that magnetic field, captured in the sub-zero temperatures, and then bombarded with microwave signals to do the probability of whether it's between north and south in the superposition. So I wanted to have intention to have a conceptual framework, so I wanted it to have a reason for the microwave signals to be sent. So I wanted to see if the scientists could turn the microwave signal into an audio, transfer an audio signal into a microwave signal to bombard the microwave, the electron with. So then I thought, well, if I read to the electron Feynman's 19-something paper on simulating physics, like the first paper about the development of quantum computers. So if I read a bit of that to the it'd be like me reading about the father to the son type of concept, like here's a little baby electron and you're reading to it the person that's actually got you to that position. And the question is that position, is it ethically and morally correct to freeze an electron like that? Where does morals happen within and ethics happen within a quantum world? That's a big question, because the hair thing is that if I took one skin cell, like they did with an American cancer patient, a woman, African American, and took a bit of her cancer and then started to grow it after she died, and so you then get a bigger body mass. Do you have is that an ethical problem or not? And I'm not saying it is, I'm just saying these things are interesting. So if you say, well, if a cell is made up of atoms, then each atom relevant to that. So when is that cell not the cell? When you see what I mean?
When life starts. No?
Well,
in reality, you are searching for the moment that life starts.
Yeah.
And in your situation, when you work with artists, how this relationship works? What do you look for?
So, first of all, chemistry. I think this is the most important in this case.
So, apart from physics, chemistry is also
apart
important.
from physics, it must be this chemistry, yes. But of course, we have in the project that I am realizing for the last, I don't know, 2 years maybe. What we do is we try to really take simple quantum mechanical processes and try to sonify them, if I may use this invented word. So we try to translate them into certain kind of sounds. These processes are usually random because these are quantum mechanical processes, but they have certain parameters that change their properties. They can be more random, less random, I don't know. They have certain properties and they exhibit certain quantum phenomena. And the question is, we want to translate it to the sound in our case. We also visualize it because we can also do the things simultaneously. And in the first moment, we want to see hear the phenomenon. Okay, this is the one element of these things. And then there is this composer who takes all this material and then works on it in terms to really make something beautiful out of it. And that's where we shut up. Essentially.
Okay. And do you feel yourself like, when they were looking for the sound of the spheres, of the planets going around, do you feel looking for that, for the noise of the universe, or it's more material, as you say?
Well, we are much more down to earth in a sense because we work with processes mostly from quantum optics, so simple quantum processes. It's not on the level of, let's say, cosmological, which, as you know, until now the quantum mechanics is not unified with general relativity, so there is still a lot of open questions there. Some of these questions are being now again addressed in the context of quantum information, in a kind of quantum simulators of what we expect could happen in black holes and things like that. And this is something that we could also try to sonify. Okay?
Yeah.
So this is the kind of, this is the program. But as I'm saying, it's a very complex process in a sense, and I need people who are very enthusiastic. But so there are several physicists. First of all, the artist has to have will to learn quantum mechanics, which is impossible to do something if they. So this is where the part of this chemistry is. But the boys or girls from the group who are participating in it also have to have enthusiasm to do it, and so on. And this is what is happening simply.
So in a way,
we are enjoying simply it, of course. But it also has some. We had this concert, as you know, in Sonar Festival last year in October. And we present these ideas and conferences of contemporary music, okay, which are again kind of niche, but still there is activity in this direction.
So in a way, there is a science communication, divulgation, in the sense that at least the artists who work in these topics, they do learn about science. So at least there is this first, you also learn about science.
And they learn about divulgation, about this, how to understand it, because we have to explain them. So for us, it's also very good training.
Of course, because you have to make an effort to disseminate to them. So it's true that at least there is this part. I was saying not so much in the physics term, that if you felt like those ones making the sound of the spheres, it was more like emotionally, like you are trying to look for you were talking about the unified theory, well, the noise of the universe in the sense of the small things, it's like, it's also
on
beauty,
the other,
I think.
one thing I want to mention, because this is maybe also the Reiko Yamada, who is composer with whom I collaborate. I actually met her at ICFO because she was a resident of the so-called STARTS program. So it is recognized by the European Union that the interaction between the technologies and science and arts is an important thing. STARTS program is a European Union program which goes from science, technology and arts. So STARTS, and they finance the residences of artists in scientific institutes where the artists can collaborate with the artists using new technologies and things like that. So this is how I met her, and then I employed her as my postdoc for certain. Now she will be already third year. So this is how this thing developed in my case. But I must say that there is some institutional help for this kind of activities in Europe.
It's good that you mentioned art residencies in science centers, because we'll be doing a roundtable on that topic in ISEA 2022 Barcelona in CERC. It's going to be on the 14th. So if you are around and you are interested, we are going to talk about that as well. When you work on your own, you work with collaboration, you also have dialogues, but what happens with intellectual property of these things that are produced? What happens with the result? You were talking about results before. Is this piece belongs to all of you? You were saying, I don't feel artist, but you are a little bit of a father of this music piece, because you've been there when it was conceived. So what is is there an issue here? Oh, it's no problem. What happens with the intellectual property of this?
Well, obviously there is some problem and one has to regulate it. In case, for instance, of our production in Sonar, there was a long play recorded after in the studio, and this is now being sold. But it's being sold by the label who did it. But ICFO has contributed to supporting this thing. So does it ICFO has property to the long play? No, because ICFO financed the scientific project of quantum randomness in music, right? So somehow we have regulated it according to my understanding. And the long play is being sold by the label who is producing it, which is Phonos, which is this electronic music. So, I mean, but these are complicated problems, I agree. I mean, in our case, it's so small money that they are not so complicated. In his case, probably they are much more complicated, but I don't know.
Well, I think it's complicated in relationship of, that a lot of art necessarily wants to have a kind of intellectual ownership of their concept. But you have to be aware that there aren't any, say, brand new concepts. Everything just builds on what's already there, and it's all a form of a sort of a plagiarism, if you like, of different things, but you're just putting them together maybe in a different way. But it's to actually make a living making art and selling art that's, let's say, abstract based on quantum is just not a profitable thing. But for this, let's say for the scientist to allow me to speak to an electron as a thing is very difficult, because it destabilizes their potential funding, because if the funding body finds out that they're doing things that they think is frivolous, they might stop funding them. So it's difficult, because there is this thing, even though they might learn something about modulation and frequencies of a voice in relationship to microwave signals, in relationship to the whole problem of stability of an electron in a space. So that idea might translate into something that's useful, but it also then you start to say, well, has that got an intellectual property in it, and should that be recognized within it? But if you look at the way that when I write a paper, I'm nearly always the sole author, whereas scientists would have 6 or 7. So they're really smart about how they do it, because they are inclusive, where art tends to be often exclusive.
Okay. I don't know if someone from the public, from the audience, you want to ask something. We are talking to the artist, Paul Thomas, and to the physicist, Maciej Lewenstein. It's now your opportunity. They are very... If someone wants, if there are no questions, I don't know if you want to ask something to each other, something that I didn't ask, and you think, I would like to know this, I would like to know why you call it a spin. Oh, there is one question.
Thank you so much. Thank you so much for this great debate. I have actually almost the same question for both of you. For you, Paul, is there something right now that you would like to still work with scientific concept that you haven't worked with yet, and that you would like to further explore in art? And you, Maciej, is there a specific art project that you would love to be able to do, concept that you would like to somehow put in the form of art?
If there is something in your work,
Because I intend to, like I said, practice-based research, I kind of follow the thing, and the work that I've got on an ISEA at the St. Paul Hospital grounds is a work of quantum chaos, and what I've discovered from that is this relationship between the quantum chaos seems to form patterns, and the relationship between the quantum computer, which seems to suggest that when you get all these entangled electrons, they will, the ability to read them might be just reading the actual where they're firing possibility. So they're going to form patterns. So I've become interested in a kind of pattern recognition idea in relationship to quantum, and that whether quantum are forming patterns that can express, or we can actually understand something about these patterns, not in a necessarily scientific way, although they might be scientific, because when I look at the patterns that are done from quantum scarring, in that stadium that they have, they call it a stadium, and they have, you just think, oh my God, it's just. Then I think they're very interesting, but I understand that the whole thing is made from a machinic understanding of how they define the little dots and so on and so forth that they think are the electrons that don't spin and so on and so forth. So science is often working with computer science, visualizing software engineers and so on to try and make it tangible for what they see, where like I don't need to do that in the same sense, but I still work with a coder because I'm fundamentally dyslexic. So learning another language is like death to me. I just can't do it. Learning English is like death to me. I failed everything at school. I just couldn't, I couldn't say the word. I just can't see it. And so it's a very, I don't know why I said that, but yeah, it's a very difficult kind of area to explore when you want to express something. And visual language is a different language to written language. And so I find that this idea of looking at the sort of visualized, the kind of patterns that one sees and the potential for meaning within those patterns, I think is fundamental to us. And it's very hard with all sort of data, like I'm working with quantum chaos data, but it's speculative, it's not real, they haven't done it to get the real data yet. And so they're speculating where the electron will appear. But it could easily be the data from the share index, you know what I mean? Data is fundamentally an abstraction of things, even though it's mathematical. But so working with a coder, trying to look at that seems to be the next thing that's starting to interest me, and that's why I started looking at quantum scarring, because not only do I love the idea that they think they're scars, but I also like the patterns. And if you manage to get to the ICEA exhibition that is on it there, you'll see the really what I'm talking about with the
yes, at São Paulo they are showing some of the art pieces from ISEA 2022 Barcelona. Also Art Santa Monica is also doing some of the exhibitions. I don't know if Maciej, you want
to answer her.
Exactly.
So the one thing that I want to mention is that it is true what Paul says, that in scientific projects we have to smuggle usually this kind of activities. So it is extremely difficult in contemporary science market, let's say, to get serious support for popularization even. I'm not even saying this kind of thing. There is a STARTS program with the residents, but to have a concrete money for a given project, it's very difficult. ICFO is helping me very much in this respect. Now I learned that I put this kind of thing in all the new projects that I write as a kind of part of the activity, and maybe I will have some better way of not smuggling in particular thing. But this is something that of course limits our possibilities. So if you ask me about the big project, of course, since I work with many body system, I would like to sonify the dynamics of the many body system. So what does it mean in music? I would like to have money to have a sonar concert with 40 people orchestra. All right, this is the thing.
So we wish for that money for 40 people orchestra. That'll be very nice. I don't know if someone wants to add something. Now it's your moment. Any of you, Paul, Maciej?
You might be interested in a project called Self. It's a project called Self, as in not self, but self with a C, where Guy Benari has grown neurons, brain neurons, and using them to respond on chips to sounds in relationship to about 30 of these brain cells and a sonification, and then allowing, so if it's playing with an orchestra, then these will respond to the sounds, the neurons will respond to the sounds of the orchestra, and then they'll create the music through their speakers in response to it. So it's quite an interesting area, you know, just to, as an experiment of whether you can transfer the,
Yeah, exactly.
So we got an exchange, interesting exchange of art pieces and information. It's good that arts influences science, but science also inspires arts. And we've seen that it's possible to collaborate between two people or more than two people, that they work in these different fields, or it's possible to work on your own. There are some issues that they still have to be addressed, but it's still, it looks like a promising area to keep on mixing art, science, and humanities. You were saying here in these gardens, we are going to have a whole cycle of activities. We are going to talk with journalists, with scientists, with artists, with sound, with also, we haven't said today, but with Oler. It's going to be a project, a citizen science project that talks about what do we smell in the city. So I hope you come to all the events, and we have a lot of people joining us with this conversation and these workshops and interviews, because as Maciej said, we need people to have more culture about science, about arts, and that's what we are trying to do. We are trying to disseminate the knowledge that is done by these professionals and these artists and these scientists. Thank you very much to everybody, and thank you to the ones you've been on the other side. Thanks.
Thank you.